Hello,
Hi.
Anton and Volodya. Did I say your name right?
Yes, nice.
Yes.
Thank you.
I'm so pleased to have you here. Yes, I have to move on from thinking about code with me and think about your session. I'm actually really interested to hear about your session because it sounds like your session is all about the sort of collaboration between the different teams inside IntelliJ IDEA to kind of help at least two products get better by working with them together. Hold on. So yes, that's right. The language support in IntelliJ IDEA, specifically Kotlin. Yes, I'm really interested in this feedback loop between different teams to kind of improve the different products. So this is a talk I really want to hear more about, and hopefully I will have a bunch of questions for this. I want to remind our viewers that you can ask questions in the YouTube channel, and our moderators will answer some of them, and some of them we can ask at the end if they don't get answered. So I will pop back on at the end of the session to ask you any questions. Let me add your slides to the stream. And yes, I will get out of your way and let you get on with it. Thanks for joining us.
Okay, great. So my name is Vladimir.
My name is Anton.
And we are going to take you on a tour to look on how plugins have influenced and changed IntelliJ. We are working in the Kotlin plugin team, and that's why I think we can share our experience quite well as plugin developers. At the very beginning, IntelliJ IDEA was an IDE just for Java. But even then, the IDE was extensible in terms of new features. It was only a matter of time before other language support would be added. At first, there were attempts to use Java with other languages in one IDE. Soon, one of the biggest changes for transforming IntelliJ from a single language IDE to a platform began. New languages and new plugins needed more functionality. Therefore, IntelliJ had to provide more extension points. Sometimes, when a feature in a plugin is perfect for lots of use cases in other plugins, it is added to the platform, to the core of platform, and can be accessed by other plugins. Finally, IntelliJ IDEA became really popular in lots of different markets due to the variety of plugins for things like language support, VCS, databases, and so on and so on. As well, many other IDEs based on IntelliJ. Yesterday was a great talk about how we support new technologies, languages, and framework from Yuri. Yuri demonstrates that with a practical example and quite well. If you want to write your own plugin for IntelliJ and have never done that, it's a good starting point. Strongly recommended. It is interesting how IntelliJ achieved that kind of success. Anton, could you please tell us how it began and how the process back then looked?
Absolutely. So, how did the platform communication look? Many things, one by one, became a kind of platform service that the different languages could use. Flexer, parser, indexes, and so on and so on. Some features was transformed easily, but others, it was a bit harder, I say. For example, yesterday my colleague Igor made a brilliant talk about the debugger. It's a very complex feature, and it's also one that can't be just taken and commonized for the different languages. We decided to keep the debugger as is, but next to it, we made a new debugger named XDebugger. It is gradually taking over the capabilities of the original debugger. And this process is not yet finished. And even the whole process of IntelliJ platformization is ongoing. It's totally fine that, it's a normal situation where you have already got all benefits from task you wanted, and then the last 5 or 10%, usually the most difficult ones, left and with the least reward. It's a kind of harmless technical debt that separates us from, I'd say, from being perfect. Why I'm saying this? It's by no means a justification for our actions, but when you write a plugin and see that some feature is specified for a particular language which doesn't suit you, you're very welcome to generalize it and send us a pull request. That would be super helpful. Eventually, one of the results of this architecture rework was that Java support itself has been extracted to a plugin too, and it uses the same platform services as other languages do. There are actually lots of great examples of how community engagement and the platform extension and interoperability. Let's quickly say a couple of words about the language injection mechanism. Everyone knows cases when the library of a language sometimes allow using another language inside, like SQL in Java or like regex in whatever. And several years ago, we held the IntelliJ plugins contest, where one participant wrote a plugin that made it possible to have IntelliJ code inside for different languages in one file. JetBrains collaborated with the author afterwards, and the plugin became part of the platform. By the way, Vladimir, has Kotlin supported in it out of the box?
Yes, the basic support, of course, worked right away. At the same time, real life usually requires a little more. In every language, you want to adapt the feature to the language. And usually, you have to polish that particular feature. I remember for language injection in Kotlin, we additionally process trim indent and trim margin cases for Python strings. So this was an example on how an entire plugin became a part of the platform. But more often, that's not. It is some specific feature, some specific things that become common. And in many cases, there are some remarkable circumstances behind the scene. Let's briefly go through several such cases. IntelliJ Hints. Originally, IntelliJ Hints were implemented in Java for showing parameter names. Other languages took notice and wanted the same ability in their environment. For instance, with Scala, that has quite powerful type inference algorithm. That means that you don't specify the type where it could be inferred from the context. They have implicit parameters and conversion mechanisms that make language less verbose and more expressive. But in some cases, you really miss the type annotation, and IntelliJ can help you with that. On this particular example, you see that type that highlighted with a red line is only visible in IntelliJ editor, and it's not available in your source code. So IntelliJ helps you here. Scala team extended this particular feature in Scala plugin for one release. They have their own extended implementation of IntelliJ Hints. Before long, the IntelliJ IDEA team began to thinking for further development, while Scala plugin has their own ideas and plans. And obviously, we in the Kotlin plugin team were impressed and wanted to get the feature for Kotlin as well. So it took some time because solution for Scala was written in Scala, and platform code base doesn't include that particular language. It took as well some time because other languages started to reuse it, and they provide some feedback. And it has to be polished for existing solution as well. But eventually, in a couple of releases, these hints got, I guess, to the final state and became available for all languages supported in IntelliJ IDEA. Anton, do you think that big changes will appear here in the observable future again?
You know, I was in the Scala plugin team when our colleague Pavel extended this feature. I tested it there, and when IntelliJ Hints started becoming accessible to all languages, IntelliJ languages, I moved on to the Kotlin project and helped with the feature quick adoption there. But, well, it actually was not that quickly. We gave a production feedback about menu restructurization, about other things, and it was fixed. In one release, it was released. in new state, and I think now everything is nice and everyone uses it. Another interesting example is it's rather about the sharing of an approach, sharing of a feature UX over the different plugins. We all know the best UI is no UI. Vladimir, question for you. How do you write Kotlin code?
I just renamed the Java file into KT files. I'm just kidding you. Sorry. Actually, I use Java to Kotlin converter. Sorry, I'm joking again.
Okay. Let's say you're writing code in Kotlin or Scala, and you have found a solution you need, but it's written in Java. You're going to copy-paste it into IntelliJ IDEA and rewrite the syntax. We initially implemented converters from Java to Scala, from Java to Kotlin. It was a quite obvious solution. But the folks from the Scala plugin team went forward and started to apply this conversion automatically when the IDE recognizes that you copy Java code from browser or whatever and try to paste it into a Scala file. This cool approach was quickly spread over all JetBrains products where possible, of course, including the Kotlin plugin. Okay, let's go next. HTTP client. It's a good example of a standalone feature being initially developed in PHP Storm, an IntelliJ-based IDE for PHP. And the feature, yes, the feature is quite reasonable in the scope of PHP, but it's also useful in other products because many of us interact with HTTP at some point. It was extracted into a small plugin and bundled to the platform. Easy way. Next, Lambda's evaluation. There were a period when Lambdas didn't exist in Java, but were already actively used in Kotlin. And at that time, the platform didn't allow evaluating expression with Lambdas. And Kotlin plugin developed its own way to do this by, as far as I remember, by using interpreter over the bytecode. After some time, when Lambdas came to Java, the solution was easily transferred to Java, and it became a common approach. So, as you can see, there are many different ways how things could get around the ecosystem. Vladimir, did I forget anything that our viewers may find interesting?
Yes, you mentioned things when the feature gets around, but we also have examples of how a thing being implemented in one plugin can improve the capabilities of entire platform. I'll tell you about build server protocol. Build server protocol defines a standard way for the build tool to interact with the IDEs, letting you import project, run compilation, and so on. The protocol is a collaborative effort between the developers at Scala Center Research Institution and JetBrains. Originally, the support of the protocol was made for the build system SBT that's used in Scala. But what it means is that any build system that implements BSP can easily be supported in IntelliJ. Okay, let's move to the extreme case. Rider. Rider is JetBrains IDE for .NET. Rider, in its early days, was a kind of fork of IntelliJ codebase where developers tried lots of crazy and brave things. Why? Rider had to fight for their user due to the presence of another very big player on the market of IDEs for .NET. To be more attractive for users, Rider has to be not only good in terms of coding, refactoring, inspections, and so on, but also provide a nice experience in terms of UI and UX. Another reason for that is that .NET developers don't like how standard Java UI looks. It's a nice example of being in a very competitive market. So, the folks in the Rider team did lots of research and tons of experiments. Later on, Rider team backported their changes to the platform and actually is built on top of IntelliJ and don't have their own fork of it. Let me recall some cool ideas of UX ideas that came from Rider. For instance, is borderless and new tabs. If we compare how IntelliJ looked back when in version 14 And with the latest version of IntelliJ 2020, you can easily see that it's way clear and not so overloaded UI. Another great feature that came from Rider is code division, where you can immediately see in your editor how many usages of this particular method, or how many inheritance of a class, or how many implementation. So you don't need to search. Everything is immediately right here. Another thing, last but not least, is a non-model commit dialog. It also came from Rider. Somebody loves it, somebody hates it, but I think it's good, and soon it will become available for everybody, and finally everybody will love it. So let's wrap the stories of features and their adoption in the platform. Anton, what takeaways can we get from this?
Yes, as you see, each feature had its own path. And it means that there are lots of different ways in which plugins can influence the platform. The ways include implement a feature or API in the platform directly, or implement a feature in the plugin and then the platform adopts it, or suggesting the idea and the platform embrace it. And finally, of course, complain about your pain points and the platform can fix it, or being a joint effort to address the problem. And what things are important here, from my opinion, because some languages and technologies are really challenging, sometimes really challenging. We have to experiment and research new approaches for their adoption and usage. And because Kotlin, Scala, .NET, so all of us, we are different. And sometimes we can suggest really cool features that are otherwise not so obvious for other languages, other products. Okay, let's go next. Besides the things that come from our plugins community, the platform itself thinks about managing all of this stuff. Active and collaborative development, has a price. We don't have a well-defined and clear border between public and private API. We try to mark some API as internal, but there are some developers who will definitely start to use it. Famous some misconceived. Anyway, there were cases of broken plugin compatibility after the platform release. Additional load on IntelliJ developers to think about compatibility. It actually prevented ecosystem growth, and it took a lot of effort to coordinate. And a couple of years ago, a solution was found. During the JetBrains summer internship, we created a tool that monitors all the publicly available plugins on JetBrains Marketplace and what actual API each of that plugin use. Now it's possible to check if your commit to IntelliJ platform breaks a plugin. It works like it works like a find usages, but over the marketplace. The check goes only for binary compatibility, by the way. Yes. And this solution, this solution allows us to clean IntelliJ API much safer. It gives us more certainty to perform cleanup during the deprecation cycle. And of course, more or less, it improves interaction with our external plugin developers. Sometimes we notify a plugin team that the upcoming version could change something, could break something, and we just try to let people know that something may happen and to take actions a time before the release. Still, there are there still are nuances because we don't see plugins from private repositories, and we don't see plugins tests. Anyway, long story short, we are doing our best not to break anything. And by the way, Vladimir, in the Kotlin plugin, did we notice the effect of the API watcher when it appeared?
Yes, definitely. And it is not the only effort that makes our life as plugin developers easy. Let's talk a bit about the deprecation policy. Why specifically the deprecation policy? Well, because Kotlin plugin targeted 3 versions of IntelliJ and 3 versions of Android Studio that is based on IntelliJ. The pain was real? Sure. With deprecation policy, we try to keep a balance between platform flexibility and the huge base of plugins on it, between ones who develop their plugin rapidly and those who just seldom maintain it. And we keep in mind compatibility for at least 3 releases that allow developers to keep their plugin unchanged for all this period. Or if a plugin is in the process of active development, you don't need to process changes in the IntelliJ platform immediately. Users sometimes ask us about the best way of supporting several versions of the IntelliJ platform. The typical solution for such cases is VCS branches. It works pretty well if you need to backport a few critical fixes. When you need to backport not only major fixes, but also new features as well, we actually don't have a good recommendation, because it becomes really difficult if you have to backport lots of changes. The most common recommendation in this case is to simply avoid such situation. One approach is to expose version-dependent API to specific modules, and build system substitute the proper model and source code directory for each version during the build. Kind of version-dependent facade. It usually works. But in the Kotlin team, we had to support the same plugin, that means with a full set of features on multiple versions of IntelliJ. But we come to a solution, and it's called bunch tool. Its advantage in keeping different API usages very close to each other in neighbor sibling files. If a file starts to depend on some specific platform version, we create a copy of it, keeping the same name but changing an extension by adding a version number. It's in this version-specific file, we write the corresponding API usage. So files for each version are available locally, and you don't need to switch branch switches. And you can easily use compare files action to see what's the difference between them. So for more details, you can just follow that link on a GitHub project. Usually, with established deprecation cycle policy in the project, it means minimal efforts, which actually inside JetBrains affects both platform and plugins productivity. Well, Anton and I have talked a lot about solutions and recommendations for concrete problems. But let's come to the core one. JVM languages made to address Java problems, going further and reaching new horizon. Can they change the Java IDE? Anton, where do you think we should to start?
Let's start from the very beginning. When you have a deal with some JVM language like Kotlin or Scala that have a good interoperability with Java, you need to make them look like the original language. For instance, you want a smooth and flawless experience when you navigate a Kotlin declaration from Java code, or finding usages or anything else. And what's important, Java knows nothing about Kotlin or Scala or Groovy. For those purposes, some kind of bridge is needed. And light classes is that bridge to make other JVM languages look like a Java. Like in the screenshot, Java code completion thinks, Java code completion thinks that it's actually a usual Java class and filled with getter and setter. How did we make it? it was a long story, and I'll tell it shortly. Initially, light classes were generated by the compiler. It actually compiled your code, generated bytecode, and got all JVM declarations like classes, methods, etc. It definitely took a too long time when IDE needed almost immediately. So we need to go deeper in the compiler. The compiler usually has the front end and the back end. The front end has a parser, lexer, some checkers like type checkers, flow checks, there is a return point from the method, and performs type inference, and so on and so on. So if your code could not be compiled, it fails some front-end compiler checks. The backend of the compiler uses all the data from the front-end and generate target code. It could be a binary code, JVM code. Okay, so now let's apply this knowledge about the internals of the compiler, what we can do with light classes. In fact, for the purpose of light classes, we don't need to generate bytecode. It's enough to use the output of the front end. So to make light classes faster, we just rewrote them into ultralight classes using only the front end of the compiler. I say this story started a long time ago, but this is actually a very big and complex feature. And so as you see, we got feedback from the first version. We completely reworked it. And finally, the full support of the new technology, ultralight classes, is available from Kotlin 1.4.20, which was released several months ago. There is actually another side of the coin in this approach. Tooling, frameworks, or whatever that interact with Java don't know when it's really Java and when it's a kind of pretender. And at the same time, pretending is not ideal. At some level, it behaves differently. For instance, from time to time, we're facing with what? UI freezes. Why? There are some implicit expectations made on designing some feature for Java. While Kotlin in some cases pretends Java using light classes, unfortunately freeze could happen because in Java you can easily calculate the type of your argument or variable, but in Kotlin you are not forced to specify types. Therefore, type inference steps into the game, and it takes some time, and sometimes much more than it expected in case of Java. Vladimir, if I'm not mistaken, you also took part in such fixing freezes, right?
Yes, we fixed lots of freezes in a Kotlin plugin and couple cases in the platform itself. I was quite happy when people from other plugin and IDEs came to me and shared their relief. They suffered from that class of freezes as well. In the meanwhile, there are several big initiatives to get rid or at least significantly reduce the number of freezes in extension points provided by the platform. It's not so simple as it requires changing of API, contracts, or even UX. Thanks to our colleague in the platform and Java team here. I would like to highlight another problem with language plugins. From one side, some languages could be similar to another in terms of syntax. You know that syntax of Java is inspired mostly by syntax of C. From other side, syntax of each language is unique. Typically, to be analyzed and compiled, programming language text is represented as an abstract syntax tree. In IntelliJ, we use slightly different terminology, program structure interface, but for the sake of simplicity, it could be considered just as AST. Let's have a look quickly on a small example for AST for Java. You see, we have a different order, some particular order, sorry, like PSI modifier, public, type element, parameter list, and so on and so on. If we try to compare it with PSI for Kotlin, it will be a completely different story, different order of elements, and moreover, for Kotlin, as you already mentioned, you can just skip and don't specify return type of your function. So, but what if we need to write down some kind of inspection, basically check that could work for both of them, or even go wider, that can work easily on all JVM languages like Scala, Groovy, Java, Kotlin, and who knows what else. So we have, let's go for some particular example. We need to create an inspection that highlights the issue of using some unstable or internal API. Let's say we have this list of internal API usage markers, and anytime if you use methods that are annotated with particular class, particular annotation, we have to report an issue, right? Well, it looks pretty easy and straightforward, but you don't want to write the same inspection again and again for Java, for Kotlin, for Groovy, where is the only difference in a language syntax. Within the Kotlin team, started to work with the platform developers closely and add another level of abstraction, and we call it UAST, Unified AST. Now it is in the platform, and any JVM language can use it. So instead of language-specific IST, like KT method for Kotlin or GR method for Groovy in UAST, you refer to U method, unified method, and the expression becomes generic for any JVM language. Okay, it was a huge step forward, and by no means the last one in the direction of how IntelliJ IDEA has become a native home for all JVM languages, with no preference to anyone. And speaking to our audience, I have to say that it's not the only technical efforts that you can solve in a code. It also requires organizational solutions as well. If your framework wants to support other JVM language like Kotlin, don't just rely on ultralight classes. Try it, use it, and sometimes it doesn't work well. Let's find a solution together. Solutions require some adoption period. Like classes was completely rewritten. UAST was actually an attempt to copy Spring support that we had in Java to Kotlin plugin. And later, having this experience, we managed to write a new abstraction. That's all that I want to say. Anton, do you have anything to add?
Well, I don't, but I want to pay a little bit more attention on the last thing, which is sometimes, let's say, it's also about convincing people who write with Java, features for Java, to switch to a bit higher level of abstraction, or just at least think about other languages. It might be hard and uncomfortable, but after tell with the people and after such discussions, you get available feedback in the very early stages. And don't miss this opportunity. In general, such initiatives are welcome because the IntelliJ platform moves closer towards generalization. And it needs feedback from you for things like cross-language operations, public API, formalization, and documentation. I touched on the topic of inter-team communication. And what can I say here? JetBrains plugins teams try to keep the distance from the platform to emulate an outside developer process. Only very special cases, like when plugin needs to get new changes in the platform immediately, it's moved to the platform repository. But it's not a frequent thing, even inside JetBrains. And the plugin teams also sometimes do, I would say, do hacks when they cannot get from the platform things what they need. And I can say that it's fine because, these hacks could be broken at any time. It was just a real life, and we are just trying to do our best. But what's important is that it's also a way of how we can provide essential feedback to the platform. And we encourage you to share the feedback too. The actions we recommend. First, tell us about what you want in IntelliJ platform forum. Just tell. Go to our Slack and discuss ideas there. Follow our blog where we publish news, and in the comments you could also discuss the ideas about that news. And if you want to take a look, at least to take a look at how the platform API is used, it still be better to start from the JetBrains plugins, because we have seen how improper solutions, say from Stack Overflow, have spread over the different plugins. We even developed a tool that show you usage of IntelliJ extension points in plugins on the marketplace. Our colleague Yuri yesterday showed it as well. So I hope we have covered well enough the topic to give you a picture of how things are going, how plugins teams behave and interact with each other, how they can help other teams and help platform to be better. Vladimir, what do you think? Let's call it a day?
Sure, let's do it. We have seen that plugins face many challenges. Scala, Kotlin are not about those languages itself. There are big horizons for experiment and new features. We've seen an example of Rider that sometimes to be a plugin is not enough, and the only solution is to have their own IDE. Some plugins organically were incorporated into the platform, while others gave birth to new IDEs. At the end, everybody wins. Our hitchhiker guide to IntelliJ is to be open. We have a big, friendly, and mature community. Ask questions, give advices, and share your feedback. Not only about some particular technical solution, but about any aspect of our ecosystem. Where do we miss documentation? Where do you feel the lack of support? Follow the platform updates and our best practices that we recommend on the different resources. Try to use what the platform already offers, but don't hesitate to invent and give some features a chance to live. Who knows, they can power other products and the ecosystem entire. And of course, your contribution is always welcome. Thanks.
Thanks for watching.
Thank you. That was really interesting. I learned a lot with that. I had mostly because I actually work with Java and the IntelliJ IDEA, just like plain without the plugin. So learning about how the different languages impact each other, that was really, really interesting because I just have no visibility over that. I like the fact that the Scala team is stealing like the Kotlin team stuff, and Kotlin team is stealing Scala stuff, and then it goes into the platform. That was really cool. I really liked that.
We call it adopt.
Oh yes, sorry, I didn't mean stealing. I meant utilizing best practices implemented by other teams. It was really cool, especially because so for me as a Java person, I'm also really pro the JVM as a platform. Like I like Java as the language, but the main value to me is the fact that the JVM is there, and you can have other JVM languages on top of it, like obviously Kotlin and Scala. I also quite like Groovy, but no one seems to talk about Groovy these days. So one of my questions was, if the JVM language can use the UAST, does it make it really easy to just add support for any other new JVM languages should they happen to come along?
Well, if you're going to write down some kind of inspection that will target your language particular problem, it's not the best way. because we use UAST for some generic problems, like I shown, using some deprecated API or internal API. Or last year, it was a big initiative for internationalization within IntelliJ, and because we have lots of different languages, we have to cover that everywhere. In effect, to write down inspection in UAST is even easier than to write it in your native language. For instance, in Kotlin, we have quite, I would say, a bit of overcomplicated stuff with all our type inferences, algorithms, and so on and so on. And UAST in many cases just nicely encapsulated, and you just use just some points like give me a return type, and you don't care how it's underneath is implemented. But at the same time, it can give you those particular the hidden problems that we talk about, and that can lead you to freezes, right? If you call Kotlin that goes to resolve entire pipeline or entire dependency to calculate your type to be inferred, it can take some time, and it can lead to a freeze. So that's why it's easy to use, but consequences could be a bit painful.
Okay, so there's some potential performance things to think through with that then.
Yes, but in general, we have quite good approaches now, and we pay lots of attention to performance problems in IDE in general, and that's good. And we try to avoid basically situation when we can freeze UI.
I guess that kind of leads me to thinking about the languages you mentioned, Java, Scala, and Kotlin are all strongly typed. So is it different for the dynamic languages like Groovy and things like that?
Well, as I already mentioned, it's not only the difference in the syntax, but yeah, you're right, in approach, how to use it. Still, underneath, we try to make some basement, right, even for dynamic languages. And from Groovy, you can access easily Java Vault, right, where you have strong types and all that stuff. To access easily from Java Groovy, well, it's painful. But in many cases, it could be goes in both directions.
Oh, well, yeah, there was another, I think this is a related question. Are there still language-specific nuances when you write something in the UAST? What do you call it? The UAST? Well, UAST.
Sorry, can you repeat, please?
Are there still, I don't know if this has been specifically answered, are there still language-specific nuances when you write something in the unified AST? Well,
we tried to, because UST is a new layer of abstractions, right? So basically you don't see any language-specific on this particular level, and that's the idea of entire approach. So in general, no.
One of the questions quite interesting is, what I liked about the presentation was how you were talking about how we can learn from other communities, not just other JVM languages. So the example of Rider I thought was really interesting, because I, as a long time IntelliJ IDEA user, I get a bit precious about changes to the UI specifically. Like, I remember when we unified all the icons and I was like, oh, I hate the new icons. And like 3 minutes later, I'm like, oh, it's fine. It's actually much, much better. And it seems like that idea, did that come from Rider then, changing the UI and making it a bit simpler? So I really like this idea of being able to use not just other JVM languages to help improve the IDE, but like other communities that are completely different languages with completely different expectations. I think that's really cool that we can, even someone as like old and crusty and set in my ways as me, can benefit from something from a completely different language, a completely different community, and bring those into the platform as a whole. I think that's really cool to be able to do that.
Yeah, another thing that is when people decide to move from one language to another. I often hear feedback from interviewers say when people say it was very easy because the tooling is the same.
Yeah,
so you don't need to learn new.
Yeah, exactly. So when I'm using IntelliJ IDEA and I'm writing JavaScript inside IntelliJ IDEA, obviously I get the benefits of being inside IntelliJ IDEA. But when you move to something like Rider, so I've done a tiny bit of C#, but not very much. But if you move to another IDE, but it still consistently kind of looks fairly similar and you have the same expectations, it means that it reduces your cognitive load, because you're like, well, it just kind of works the same kind of way, and I get what it works the way I expect from my IDE, and that's really cool. It just makes things a lot easier for developers, I think. But I had a sort of follow-up question from that. I like the way that you can take things that work and put them into the platform, for example, but are there things which seemed like a good idea from one community and then you try to generalize it to something broader, but it didn't really work out?
Actually, this happened. It could happen because of maybe very complex things in implementation, and yeah, usually it's a matter of a technical solution. Yeah, I can't remember the specific features. What the question means that this feature will not need it, for everyone, right?
Right, basically, or like I sort of thinking about things like workflow. I guess the commit window is an example of something which did work but might not have worked. The removing the mode or commit. Is there anything that kind of looked like it should have worked, but like no, it's just, I don't know if it's technically or just like from a user mindset point of view. Is there anything where like maybe a Java developer is just never going to embrace the I don't know, C# way of doing something?
Well, for instance, that particular feature with code vision that I showed for Java, it could be available in any other language as well. But for instance, for Kotlin, we don't imply it due to the performance problems. If we start using it, it will immediately ruin the entire experience of using this particular feature. So we tried, we tested, we checked, and said, well, we have to do lots of other stuff so far to enable it by default, or even give people to ability to enable it, right? So this particular feature is basically disabled. If you're able to do some stuff like the path that took for IntelliJ Hints to come from Scala, it has to be completely rewritten from Scala to Java or to Kotlin to be supported from platform inside. But other things, maybe they are still in progress and we just don't know that particular names. Who knows?
Yeah, and maybe, and I like the thought that maybe it seems like a good idea, but it's just not needed across the board.
Sure.
Or, yeah. No, interesting. Let me check for other questions. No, just more observations. Like I like the way that you presented. Actually, I like the fact that you were like riffing off each other the same way that you're sort of suggesting the different teams and different plugins riff off each other. It was really cool to sort of see that. Like it's all about, for me, it's all about collaboration and working together to get something which is going to benefit everyone. And it was really cool. I don't know if you have any other comments, questions, anything you want to wrap up.
Well, basically what you highlighted, we try to share our experience of working in the shoes of plugin developers and not the people from just inside of IntelliJ. They can do everything, right? But how it's easy or how it's difficult to write, to use our platform and to create some big and valuable plugins like Kotlin is. It was our goal.
Cool. Great.
Yeah, often in our bug tracker, issue tracker, we see a request like, "Hey, I see the cool feature in that plugin. Please implement it in this plugin." And we want to encourage our users, just to keep looking in other places and suggest us to do this. It's a really nice approach, and even if we monitor things that happen in other plugins, in other teams, we still can't miss something or just overlook something. Yeah, and if you think that it's it will helpful for this community, just suggest it. Yeah.
I think it's really nice to be able to utilize the so-called polyglot programmer, because someone who uses a bunch of different environments and a bunch of different languages, they can kind of say, well, this actually really works. Maybe we could try it somewhere else. And I like that idea. Cool. Thank you very much. I will let you get on with the rest of your day. And yes, thanks very much for your very interesting talk.
Thank you.
Thank you. Thank you.
Thanks. Bye.
Bye-bye.